My goal was to have a book that made it easier to use the tools. So it's definitely a product-oriented book as opposed to a theoretical, discussing all the finer parts of parallelism and so on, although obviously the parallelism topics are covered in the book. And what I wanted to produce was a book that someone could pick up and read and use it as a self-contained sort of teach-yourself book on parallelism, and in particular on using Intel Parallel Studio. So that's how the broad concept sort of appeared in my own mind, and I think largely we've stuck to that, and it's worked out quite well. So for instance, you'll see in different chapters, every chapter apart from the first two chapters has a hands-on section, and there's source code with every chapter. So and guidance is given in the chapters on how to try out some of the techniques for yourself. Towards the back of the book, we've also put, I say we because I co-authored this with Andrew Stokes. Andrew Stokes is a colleague from university. I used to work at a university a number of years ago, and Andrew was a colleague then. So he co-authored and did some of the chapters with me. So as part of this interest in making it practical, we also wanted to put some case studies together. So in towards the back of the book, there are 4 case studies, which again have got code attached to those chapters, which the reader can download and try out. And I describe the book as being it requires some technical knowledge. There's an assumption of the being able to program in C. So all the examples in the book are either in C or C++. There's no real requirement for being a C++ guru, but there's some code in there that uses C++. And where I've done that, on the whole, I've assumed that the people doing it don't have a huge knowledge of C++. So as long as there's a programming knowledge and a reason, someone who's sort of technically savvy, so that they're able to write programs and compile them, that's the starting point. But beyond that, I've not made any real assumptions. So, and I say the book doesn't just talk about parallelism, it actually talks about using other features of the tool set as well. So we look at how to generate safe code, doing security analysis on code, or how to optimize code, how to get the compiler or you can use the compiler to generate code at its most optimum, how to use the reporting features of the compiler, and so on. And then apart from the code generation side, then there's also some more they're tougher subjects. So doing an architectural analysis of your applications using Amplifier XE. So with Amplifier, it's possible to do some fairly low-level analysis of how well is the program using the CPU. And when I've introduced those topics, I've again not assumed that the readers are experts on architecture, but rather I've introduced the topics and hopefully given me enough in those chapters so that people can try out analyzing using Amplifier to see how well their code is performing on the CPU. No, not really. There are examples of threading building blocks. So in the implementation section, then some aspects of threading building blocks is used, but we made a decision not to go too deeply into threading building blocks because there's a separate, an excellent book written by James Reinders which covers that in more detail. And so because of the scope of what we're doing, we're trying to cover the 4 stages that we encourage people to do in terms of making parallel code, doing the initial hotspot analysis, implementing the parallelism, looking for any errors that you've introduced, particular threading type errors, and then tuning the parallelism. Within those 4 steps, then at the implementation stage, we have given some examples of how to use threading building blocks, for instance, for making parallel loops and so on. But our focus has not been heavily on C++.